So an overview of the session today, we're going to talk about the process to date on PFAS. We're going to do a quick overview of the science. We're going to talk about where we expect to see PFAS in Massachusetts. We're going to talk about the proposed PFAS NOL category, tools and assistance available from the program, and some specific examples of PFAS NOL. So with that, we'd like to do a quick poll and see a little information about whether people think they're using PFAS in their facility or not. So Pam, could you launch that?
Okay, I've launched the poll. Go ahead and complete that. It's a pretty quick one. I'd like to see everybody complete the poll. We're asking, does your facility or client use PFAS chemicals? And the options are not likely, possibly, but I can't estimate, possibly, but likely less than the reporting threshold. Yes, but below the reporting threshold, and yes, likely above the reporting threshold. So we tried to keep it fairly easy to figure out. Give it another couple of seconds here. If you haven't completed the poll, go ahead and do it. And I'll stop here and share the poll. So interesting, Jim Curran points out that we should probably have also had the option PFAS or used, but not listed PFAS. So Heather, what do you think about what you see there?
I guess it's, I guess it's pretty much what I would expect. Maybe like I would have expected a little bit more in the yes category above reporting threshold. But breakdown wise, I think that is, pretty much what we would expect.
Okay.
Okay, I'm just going to go. Okay, so interesting. Okay, thanks for answering that. So, so to start off with, we're going to talk about the process to date for PFAS NOL. So we started review at the Science Advisory Board in November of 2016. We started with some super easy PFAS, PFAS, and PFOA. And I know the acronyms get tricky, as do almost anything with PFAS. But we started with PFAS and PFOA, which have really basic PVT characteristics. And the board made a recommendation to list those, and then we moved on to other PFAS. While we were doing that review with the Science Advisory Board, we were beginning to develop the policy analysis. And as probably everybody knows, the policy analysis has a summary of the science, estimated use in Massachusetts, options that are available for alternatives, other regulations that apply, and predicted impacts to the TURA program. So as we got through information at the Science Advisory Board for the science, we were writing that up, and we were simultaneously trying to research what use was in Massachusetts and develop that along the way. And those drafts were presented at the advisory committee and the administrative council periodically along the way. In the beginning, very incomplete. And then finally, as complete drafts in the last one was October of 2020. And the last two at the administrative council were March and August of 2021, where the administrative council made a vote to list. Draft regulations went out at the end of September for a public comment period. We had a public hearing on October 15th of 2021, and the program is currently responding to comments. And I just want to take a minute and talk about the difference between the TRI PFAS and the proposed TURA PFAS NOL. So during that time frame, TRI listed 172 PFAS that were reported reportable for reporting year 2020, and those were added through the National Defense Authorization Act. Those substances are reportable individually, and the reporting threshold is 100 pounds. And TRI is still adding additional PFAS. They've added 3 new ones in 2021, and they plan to add more. So that's definitely something to keep an eye on. For the TURA, proposed TURA PFAS NOL, that's a category. So all those PFAS NOL are reportable together as a category. And the proposed reporting thresholds are the typical TURA thresholds of 25,000 pounds manufactured and processed, and 10,000 pounds otherwise used. So just want to make sure, I know it's confusing that there's a couple different things going on. I just want to make sure people are aware of that. So back to the proposed PFAS NOL TURA category, the response to comments the program is working on and planning to complete by the end of November. If regs are promulgated in December, then reporting would begin in reporting year 2022. We have received some comments asking us to clarify the definition. So look for some clarifications to the definition as we're responding to comments, and possibly some descriptive factors for the name. For instance, even though we have PFAS NOL, PFAS not otherwise listed, this isn't all PFAS, as somebody just mentioned. So we might add a descriptive word like certain PFAS NOL as we respond to comments. So to summarize the scientific information from the Science Advisory Board, you'll see page numbers listed in this part of the presentation. Those refer to the policy analysis, which is available on the TURA website. We do have a website that has a whole bunch of PFAS resources, including the policy analysis. So you can go take a closer look at that if you want. And we've kept the page numbers in here in case you want to do that. So as I said, we started with PFAS, and we started with PFAS and PFOA, which had really basic PBT information and were pretty easy listings. So both PFAS and PFOA are special for a couple of reasons. PFAS being the fact that there was just that really basic PBT information, and PFOA was special because there was quite a bit of epidemiological information from the C8 Health Project in Parkersburg, West Virginia, where 55,000 people were drinking PFOA in their water. And as a result, there was quite a bit of epidemiological information available for that. So even though PFOA was an easy recommendation for the Science Advisory Board, they still spent a fair bit of time looking at the epidemiological information for PFOA to think about what characteristics they may see in other PFAS that have less information available. So after looking at those two, we broadened the range of PFAS that we looked at, and we up to PFNA, which is a C9.
We've got a freeze.
I'm happy to hear it's not just me.
I was just making sure it wasn't me as well.
Yes,
Yeah,
hand freeze. It went dead.
Yeah. And she has to get out and get back in again.
So I didn't lose connection.
Oh, you didn't?
Oh, we can hear you
No.
again.
It
Yeah,
said
you
the host muted everyone.
Hmm.
Where was I?
You had just mentioned PFNA.
PFNA. Okay, thank you, Carolyn. So yeah, I don't know what happened there. So after the Science Advisory Board looked at PFAS and PFOA, we looked at a wider range of PFAS, up to the chain length C9 for PFNA and down to C4 PFBA and PFBS. We knew that that companies were switching to shorter chain PFAS and also to ethers like GenX. We also used information that was developed by the OECD which had developed a really long list of PFAS and categorized those into kind of like high-level categories and some subcategories. And they had also identified whether the substances were precursors to PFAS. And so that work was really helpful to us as we move forward. And we kind of followed their high-level categories, looking at PFAS, the ethers, Gen X and Adana, and phosphonic and phosphinic acids. And so those were their high-level categories. So the SAB reviewed various health impacts for those, as well as a number of degradation and transformation pathways through which the PFAS precursors could break down into one of those end degradation products. And here's the high-level summary of chronic health effects that we saw across the chemicals that we looked at. So as I said, PFAS and PFOA were a little bit special. PFAS, we didn't really have to look at much because it had such strong PBT information, and PFOA we looked at extra to learn as we moved forward. But we looked for, we were finding effects in cancer, immunotox, thyroid and other endocrine effects, hematological effects, liver and metabolic effects, repro-developmental, neurodevelopmental, neurotox, asthma, and then we had a list of anything that we saw that was significant. So you can see where we saw effects for each of these specific substances as we were doing that review. And the X is a high level check. There may be potency differences, and there are potency differences between PFAS that are listed here. And I also want to mention in the policy analysis in the appendix, the same table exists, citing the study that was used to develop this. So we did the same thing for environmental effects, same group of, same list of PFAS, and we looked at persistence, bioaccumulation, which includes phytoaccumulation, presence in the environment, and presence in biota, including humans. And this is where the Science Advisory Board saw effects. So I think I've said most of this about precursors, but so in addition to reviewing the hazard information, the SAB looked at degradation and transformation pathways for really all the subcategories listed in by OECD. And those are the pathways through which the PFAS precursor breaks down into one of the end degradation products. So it might be hydrolysis, it might be photolysis, or other types of degradation. The SAB also reviewed that OECD spreadsheet and their methodology for identifying those PFAS precursors as they were looking at those degradation pathways. And the chemicals for which the hazard information was presented on those previous two slides are the end degradation products, in addition to sometimes being used intentionally in manufacturing. So why do the raw materials and commercial products matter? Why do the things that break down into those end degradation products matter? So here we have an illustration of why they matter. So the terminal degradation product that we might find in a community might be PFOA, but the commercial product that was used that caused that contamination is AFFF. And the raw material that was used to manufacture it is the 8,2-fluorotelmer alcohol. So, so that's why if we're taking a preventative approach, we can't just look at those terminal degradation products, but we have to back it up and see what was being used to achieve that. So to wrap up the science portion here, this is the recommendation from the Science Advisory Board, and that recommendation was to list PFAS that contain a perfluoroalkyl moiety with 3 or more carbons, or a perfluoroalkyl ether moiety with 2 or more carbons that are not otherwise listed. Most of what's otherwise listed is going to come from that TRI PFAS listing, but not all of it. So we're going to talk about a lot of examples later in the presentation, but this is kind of like the end of the science portion this morning. So I thought maybe it would be a good time to stop for questions, especially since we had a little glitch in the middle there.
Yeah, Heather, we lost about a dozen people at the same time. Pam got kind of kicked off there. So but they're all back on. So for slides 8 and 9, after your PFNA, and then just maybe you want to say a few words about what was on slide 9 for those that were busy getting back on. And then they were back on for 10.
Okay, so for slide 9, these are the chronic health effects that the Science Advisory Board looked at. There were a lot of health endpoints that they looked at. Across the top are the PFAS that were listed on the previous slide. And then the Science Advisory Board looked at cancer effects, immunotox, thyroid and endocrine effects, hematological effects, liver and metabolic effects, reproductive, developmental, neurodevelopmental, neurotox, asthma, and we noted anything other that was significant. So the X's are where the Science Advisory Board saw effects of a concern. It doesn't mean that the substances that are along the top have the same potency. In fact, in many cases they don't. But a lot of times the shorter chain substances, for instance, are showing the same health effects, but lesser potency than the original PFAS. So those X's represent effects, and the policy analysis in the appendix cites the studies that were used to come to that conclusion. So if you're interested in that information, it's available there.
Thanks.
No problem. Were there any questions on this specific part of the presentation before I move on to the kind of the next, which is more focused on use?
I have a question. It's Lucy.
Hi, Lucy.
On slide 7, you mentioned that that you think that the regs, if regs are promulgated in December, reporting would begin in reporting year 2022. So would we start tracking in 2022 and then
Correct.
report in 2023?
Correct.
Okay. So reporting would actually begin for reporting year 2022 and 2023.
Yes, reporting in
Okay.
2022, reportable in July of 2023.
Okay, cool.
And Heather, Daryl has a question. Are there any rules of thumb about how health effects align with chain length or number of carbon atoms?
That's something we struggled with deeply, and I'm gonna say no, that there's not really any overall there's not really overall rule of thumb that you can really hang your hat on. Liz, do you have a different opinion on that?
I was going to say not so much on the health effects, maybe where you saw like liver effects and metabolic effects across all of them, but perhaps in the bioaccumulation, where the shorter chains tend to phytoaccumulate, meaning they build up in plants and the roots and shoots of plants, and the longer chains bioaccumulate in biota and humans. Is that fair to say, Heather?
Yeah. Yeah. And in the beginning, it seemed like there was going to be a rule of thumb, but it just didn't pan out in that, like, something else always seemed to crop up. I guess that's how I feel about it. Like maybe one effect seemed to be like less potent once you get to a smaller chain, but then something else pops up.
Yeah, I guess one other thing that it's not really a trend, but the how long they stay, their half-life in your body, for instance, in humans, it is definitely a shorter time for the lower, the shorter carbon chains, and a longer time up through like C8, right? And then it either levels off or changes a bit.
Yeah, but also different between like the sulfonic acids.
Yes.
Right.
So
longer, yeah.
PFHXS, the C6 sulfonic acid, has the longest residence time of like a half-life of maybe 7 years in your body.
Mm-hmm. All right, I can answer any more questions about that. At the end of the presentation, I just wanted to stop and make sure we're all together. Okay, so the next section here is, talking about where we expect to see PFAS in Massachusetts. So as I said earlier, while the Science Advisory Board was doing that review, we were also trying to learn about where PFAS are used in Massachusetts. And as you know, if there's no reporting information already, it's really hard to figure that kind of thing out. So a few years ago, OTA had an intern that looked up these industries that are cited in the literature as being ones that are likely to use PFAS, and did research on what the companies were in that industry code in Massachusetts, and did further research on the companies to try to determine if they were likely to use PFAS or not. So that was kind of our starting point. And also we used tier 2 information as well. So in terms of expected uses in Massachusetts, plastics and resins is one. So fluoropolymer resins are used to manufacture products where heat, low coefficient of friction, or chemical resistance are needed. Uses in Massachusetts would include insulation and jacketing of wire and cable. And we expect to have several filers in this industry sector that will trip thresholds. So this is a higher volume use and a higher volume of the product, a higher percentage of PFAS in the product. And we would expect to see some filers in this industry sector. And here's an example of an SDS for that type of use. It's the Daikin Neoflon flowable resin. We've got the section 3 circled in red here. They've kindly given us the CAS number and the name of the substance, perfluoroalkoxyalkane, and at 100%. So we can see it's high percentage in the product. And again, it's probably like a higher volume use. So easy peasy to figure out if you need to report for these guys. The next use that we expect to see in Massachusetts is in coatings. You can't really think about PFAS without thinking about cookware and Teflon coatings. So those would be included in this use category, but we don't think we have anybody making cookware in Massachusetts. But they're also used to reduce friction on the surface of medical devices, such as catheters and guide wires, and can provide finishes that stand up to the autoclave and provide color coding, so they're useful in that way. And again, we expect that we might see some filers in this sector. I think we have a couple examples of products that might be used for this use. So we have the CASWELL PTFE dispersion, which is polytetrafluoroethylene at less than 55% weight percent. And again, they've kindly given us a CAS number, which is always so nice. So what are we gonna do here? Anyone wanna say how they would approach it?
And you mean with respect to figuring out whether or not you trip the reporting threshold?
Yes, or whether you need to report.
I think you would have to start looking at your manufacturer of the product, and maybe even your use and how you dispose of it.
All right, good. So you're going to find out how much of the product you're using and what are we going to use as the percentage to determine whether you're going to trip the threshold.
Looks like 55%.
Awesome. And we're going to check the CAS number to make sure it's included in the category, right? So still fairly
Yeah, I would also check to see if they have an updated MSDS, because this one's pretty old.
Pretty old. Perfect. Okay, so still pretty straightforward here. And then we have a different SDS for the Chemours PTFE fluoroplastic dispersion. We have a different chemical name here at the bottom, but they've kindly at least given us that, and a CAS number and a much smaller percentage of PFAS in the product. So same process as last time. We're gonna check that CAS number and see if it belongs in the category, how much we're using of the product, and what are we gonna use for our concentration to determine whether we need to report or not.
So let's also quiz everyone on what is it that was actually listed under components? Is that the major component of this dispersion?
No,
No,
No.
no. In fact, what is the dispersion? It's a PTFE dispersion, right?
That is true.
I think this is a case where you got to get in touch with the manufacturer to get additional information.
Good point.
And here you would have to use the average, right? To determine whether or not you trip the amount, trip the reporting threshold.
Right. That isn't a fluorinated chemical, though. That's another ingredient. So you would still have to check and see if it's on your list.
Correct. That name was so long, I didn't even notice that.
So I think it's important to note that many times fluorinated chemicals, particularly the resins like PTFE, these are going to be tiny pieces of PTFE and oligomers, et cetera, and they're not going to be on your safety data sheet. So you're going to have to do some rooting around in the technical data sheet or the name of it, or some other hints that Heather's going to give you later to find out whether there are fluorinated chemicals in it.
And maybe we should have been suspicious with the prior one that had so much PTFE, and this one that is listing the small amount of the other chemical.
right. Can I ask a question? So I know that these are going to be listed as categories. Are you going to give a list of CAS numbers? I should probably know that from looking at the proposed, but is it, do you give a list of what might be in that category, Heather?
Yeah, so our plan is to provide a list of CAS numbers that are known to be in commerce, and whether they meet the category definition or not. So that doesn't it's not a exclusive list. There could still be other substances, especially if they are, especially if they were, CBI. So that doesn't, preclude having to reach out to the manufacturer and ask questions, but it will give you a lot more information about what CAS numbers you need to look for.
And Bill has a question. Go ahead.
Yeah, sure. That was one of the concerns that I had about the category, was that there are several thousand PFAS out there, which we know of, and the majority do not have CAS numbers. So that international list, is that going to be the list for the otherwise category?
So, so it is it is a lot to keep track of. So we've got the list of TRI substances, which have CAS numbers, which is so nice. We've got the list of substances that we know are in commerce from TSCA, and that's really helpful too. The only problem with that list is the CBI. So for the chemicals that we know, we can determine whether they belong in the category or not, and provide that information. So that's a pretty helpful piece, but it's definitely not the end all be all because of the CBI. So for substances that you're using that were claimed as CBI, those you'll really have to reach out to the manufacturer to ask whether they fit in the category or not. And we'll talk a little bit more about all of that a little bit later in the presentation. But yeah, it is tricky.
Thanks.
Yep. All right, so we'll move on to the next use, which is metal finishing. So PFAS are used as fume suppressants and chrome plating, as well as in electroless nickel and copper, plating applications for lubricity. We definitely know that it's being used in Massachusetts for these uses, but we think the quantities are probably going to be below threshold. So we don't really expect to see a lot of filers, but we do know that people are using PFAS in these applications, and it's a really important sector in terms of exposure and releases to the environment. So even, if companies aren't filing, we still want, them to learn about their PFAS usage and make sure that they're managing it properly and looking for alternatives where possible. So this would be a great place to do an alternative plan for a substance that you don't have to report on. Daryl, did you have a question?
I was just curious if you think that the metal finishers know that they're using PFAS, or are they buying products that just say fume suppressant and it's been not listed because of low concentration or something else? Is that something that's easily identifiable, or something that they would be specifically requesting, or they're just getting it as part of something they've been told by a supplier would solve their fume problem?
So I think all of the above. I was at an NASF session about a month ago where, overall the industry group is pretty aware that, that platers are using PFAS, that it's a problem. They're educating their members to make sure they're looking out for it. So there's definitely some education going on through the industry group, which is great. I definitely heard somebody at that, one of the members at that meeting make a comment about using a product that was PFAS free, and didn't seem aware that they still had a whole other group of PFAS that they needed to be worried about. There's definitely platers that are much smaller and not part of industry groups. And then, of course, there's the whole issue that you're bringing up about whether it's not going to show on the SDS or not. And we have a couple of those, I think, that we'll look at here. So here's the CASWELL chrome fume suppressant. Super long name substance here. One of my jokes is when you're looking for PFAS, just sort by the length of the name first and start there. So this is one of them. And this is at 8%. So it is on the SDS. It does have a CAS number. So that's nice. So that's good. I mean, that's some information that will be helpful to the people that are using it. We have another one here, which is a 3M acid mist suppressant, fluoroalkyl acrylate adduct, no CAS number, so bummer. So, probably going to have to reach out to the manufacturer to get more information there to determine whether the substance would be covered. It probably is covered in the category, but more information is going to be needed. And I think you're right, Daryl, with the surfactants, it's definitely possible that it's in a really small quantity below de minimis, and that's problematic as well. But it's not here. These are in pretty high percentage. So another expected use in Massachusetts is textiles, with typical applications being stain and water repellency and military or firefighting gear. Also used in performance outerwear and footwear. And oftentimes trying to make mil spec to keep the weight of the gear down for either those military operations or similar application for firefighting. There are definitely some facilities using PFAS in Massachusetts for this purpose. And there is also a grant through TURA this year, working with the Nantucket PFAS Action Group, looking to replace out the firefighting gear with PFAS free. And hopefully we will learn through that project a little bit more information that could help us help filers. Again, here's a SDS that's for that type of application. Again, it's a fluoroalkyl acrylate copolymer, no CAS number. And my percentage, I think is hidden because it's percentage, so that's nice. So again, some work is going to have to be done here to go back to the manufacturer, double check to see whether it's included. It probably is, and then go from there. Another expected use in Massachusetts is paper. PFAS are used for grease resistance and food packaging. We don't think we have anybody manufacturing food packaging here in Massachusetts, but we clearly have plenty of people that use it. Even manufacturing facilities that use that. And then PFAS used in paper facilities for coating various types of performance papers. So an SDS for this type of use is the Dakin paper grease, another one of the fluoroalkyl acrylate copolymers. So same old as the last one. Electronic components, PFAS are used as surfactants and etching solutions. There's likely many users in Massachusetts that would be using PFAS for this application, but they're likely to be under threshold and using really small quantities. There is a grant through the Department of Plastics Engineering and Transcene, and I had to make myself notes on this to remember. Okay. So they're researching safer chemicals to replace the PFAS surfactants and studying the compatibility and stability of pectin-based biosurfactants and etching solutions. So hopefully that will help Transcene phase out their use of PFAS and hopefully translate to other industries and possibly even other surfactant uses. Another application, surface cleaning. So HFEs do meet the PFAS NOL definition. Popular products are HFE 7100 and HFE 7500. We did see quite a few mentions of those in the tier 2 data. And surface cleaning, is an application that we're pretty experienced with. We don't expect a lot of people to trip thresholds for HFEs. They're pretty expensive, so being over 10,000 pounds for that is kind of a lot, but still important to keep track of this use of PFAS. And there's definitely, a fair bit of expertise in the program to help companies switch out. So we have a few different SDSs covering this type of use. Oftentimes the HFEs are paired with trans-dichloroethylene. Here we've got methyl nonylfluorobutyl ether and methyl nonylfluoroisobutyl ether. Proprietary percentages, so that's tricky. So we'll have to figure out the percentages that we're going to use there. And then because these are both members of the category, we're going to add those together to determine whether we're meeting the threshold for that category. Here we've got a Fluosolve solvent, where we've got a proprietary fluorinated fluid blend and a proprietary solvent. So again, there's going to be work to do to figure out whether that proprietary solvent would be reportable or not. Another example is the 3M Novik 72DA. So I think we've got 4 substances here for PFAS here that would be part of the category and in various percentages. And lastly, for these SDSs on surface cleaning, is the 3M Novik 7100. Again, we've got 2 fluorinated substances and various percentages. So anybody want to take a venture of what we're going to do with these percentages here? We're going to find out how much of this product our company uses. We're going to check the CAS numbers to make sure they're covered. And then what are we going to do with these percentages?
Wouldn't you take the midpoint of the two of them together and
Yep.
use that as your means to calculate?
Yes, so we're going to take the midpoint of each and then come up with the amount for each and add those together.
On those occasions where you have no upper bound or no lower bound, then you take the highest, right?
Yeah, you take so when you have no lower bound, you take the highest. When you don't have an upper bound, I'm not sure if I've seen that.
Yeah,
But
it's
yeah,
usually that you don't
take
have the lower bound. It's
yeah. So yes, thank you. I think we're almost through expected uses in Massachusetts. So petroleum products, we have some companies that are manufacturing lubricants. Those would be, fairly high volume manufacturing, so there could be some filers there. One example here is Loctites. They've listed no hazardous components, no CAS numbers, no percentages. However, in the product description, they're saying that they have PFPE, base oil, and a PTFE thickener. So we know that the PTFE at least is reportable, and we'll have to go and check and see whether we're gonna need to report this or not.
Heather, Karen just posted a really interesting point. She says that she's familiar with some of the Novec products you were talking about earlier, and that they have moved to those as replacements for greenhouse gas products. So there is this issue around prioritizing elimination of PFAS over reducing greenhouse gas usage. And what do you think about that? What are your thoughts?
Yeah, and that's always, there's always trade-offs, and that's always tricky. So, with any substitution, you have to evaluate, what's best for the company. How can you manage the alternatives that you're looking at as best you can, and what are really like the least hazardous alternatives that you can use for any given application. So yeah, I think it's always a trade-off.
So Heather, just add to that ideally, if they're greenhouse gases or if they're PFAS and you need to use them, then you just need to try to make sure you're doing the best job you can and not losing them and not emitting them to the air or exposing workers, et cetera. So there's always ways you can tighten up your process.
Right, like your TUR, could be improved O&M. And definitely, I think like the first step of everything that we're doing with PFAS right now is hopefully making sure people are aware that they're using PFAS and that, they may break down into something that would contaminate a water supply in the environment. And, using that as safe, for what they have to keep using that as safely as possible and just being as knowledgeable as possible about it while they're looking at alternatives. Let's see, I must be almost done with uses in Massachusetts. AFFF, not typically an industry use. Municipal and government uses of AFFF are not covered under TURA. However, there are some companies that put AFFF into product. So if you're processing it to put into a product, then that is reportable. And we know that there's at least one company that does that. And then TURA has a project going on with AFFF and the Department of Defense to help them assess alternatives. First coming up with what the important criteria are for AFFF and assessing alternatives, and then doing alternatives assessments to help move the research on AFFF along. So just to summarize some of the important things from like that section of the presentation, Check your SDSs. We saw a lot of examples of a lot of different things going on in the SDSs. Things to look out for, keywords to look for, fluorinated, those sorts of things. Sometimes abbreviated as PF, something. So these are some examples of what people will have to look for as they're assessing their use of PFAS. The de minimis for all PFAS is 1%, so it's definitely possible that they are in products at less than 1%, except for PFOA is 0.1%. So applications that PFAS are likely to be present at less than 1% are surfactants and processing aids. Their presence are still important, even if it's not reportable. Again, like, we want to make sure that companies know what they're using and are handling it in a way that wouldn't cause contamination of a water supply, which is really not good for anyone involved. So at this stage of the game, we're trying to gain knowledge. So we'll talk a little bit more throughout the rest of the presentation about how to navigate this. One thing that some companies are doing some effluent testing. It's definitely not required, but it is an option to try to, if you're someone who likes to do a double check and a triple check, and you're maybe concerned about what your supplier is telling you, it is an option to do a little bit more do a little bit more research to see whether there's PFAS anywhere in your facility. And with that, I think I'll hand it over to Carolyn.
All right, thanks a lot, Heather. So I'm going to talk a little bit about ways that that OTA can assist with some of this identifying PFAS work. And when you're trying to figure out where PFAS are present in a given company's operations, part of the equation there can be reaching out to suppliers. And we know that suppliers are not always super cooperative with that, but we want to help with that outreach wherever we can. So when that 2020 TRI listing was made, OTA developed a supplier notification letter to help companies determine whether there are PFAS in the products they're using, basically to tell companies, we're subject to these reporting requirements now. We want to know what's included in what you're providing us, and we don't want to be using anything that's subject to this reporting. And we're going to be preparing a similar letter to assist companies with communicating with suppliers about this new PFAS NOL or certain PFAS NOL listing. This is the tool that John Rashko was talking about in chat a few minutes ago. So keep an eye out for that new letter. I'm going to drop a link to the TRI supplier letter in the chat right now. And it's also in the conference materials, so you can see what we've used so far. And I'm also going to drop a link to the sign up link to OTA's newsletter so that you can get a heads up when the new supplier letter for the new PFAS category is available. Next slide, please. So we know that companies are facing some impediments in addressing PFAS, and some of the ones that we hear about commonly, and I don't think any of these will be unfamiliar to many of you. Lack of awareness. Even companies that don't want to be using PFAS don't always know they are. And as Heather mentioned, and as I'm sure a lot of you know, PFAS often don't appear on SDSs, or they appear in kind of cryptic ways, as we've covered. Manufacturers of products that companies are using often withhold information about PFAS as proprietary, and suppliers often aren't all that helpful or responsive when you reach out to them. And there's also the problem that companies might be using PFAS contaminated feedstock. It might not be a product, it might be recycled paper or tainted well water. So it can be hard for companies to figure out where PFAS might be present. So as you're supporting companies with this, really consider some of those alternate possibilities too around other sources other than necessarily just products that companies are actively using. Regrettable substitution can be an issue. That's something that we're hoping to address going forward by listing this big category of PFAS so that we can, encourage companies to pursue alternatives. But over the years, a lot of companies have traded out C8 for, these 6 or 4 chain PFAS. And as we talked about, there are still health concerns with these, and we still see persistence with these shorter chain chemicals that we're concerned about. concerns about liability can get in the way. You know, there's no incentive for a company to test for PFAS if they don't know it's there, if they're worried that liability might result from that. And again, you know, with that incoming feedstock issue, we know that lots of companies want to be good citizens, but if a company tests for it and finds out there's a problem, a lot of companies would be worried they might be subject to misplaced liability if they find out about it, even if they're not the source. And over the years, there hasn't been all that much regulatory pressure to do anything. You know, one of the drivers that we have here in Massachusetts is that for companies to renew their wastewater discharge permits over the next few years, some of those permit renewals are going to start requiring PFAS testing. But, you know, top policy change, implementation is slow, and it's also taking a while to get suitable testing methods for some of these media like effluent to be developed. Beth just asked in the chat if something's proprietary in an SBS and the supplier isn't cooperating, would you need to do anything other than documenting the attempts to obtain information? I think that is a really good, I think that's a really good kind of good faith effort demonstration. I don't know that I would recommend anything other than kind of taking those steps. I don't know if any of my other TURA colleagues, TURA program colleagues have thoughts about that before we move on.
Would just add that it would be good for you to let OTA know that there's a company that's not willing to share that information, and maybe as the state we can ask them as well to please let their supply chain know.
Mm-hmm. That's a great point.
And I would also say, not specific to TURA, but you know, even if they haven't let you know, you still own the liability if if there's a problem with the PFAS. So, you know, it's obviously best to have the best information possible. I guess just that one.
Yeah. We can go on to the next slide, Heather. So Mass DEP has flagged some specific drinking water protection areas where they wanted to work with the TURA program a little bit to prioritize some PFAS outreach efforts. So here at OTA, we worked with the local EPA regional pretreatment coordinator and with Mass DEP and the MWRA, and we set up some lists of companies upstream from these local wastewater treatment facilities who belonged to the industries we were interested in looking at more closely. Heather shared some of these earlier and talked a little bit about the work that OTA's interns did to try to identify some of those industries where we were concerned about PFAS use specifically. And the goal here was for OTA to be able to reach out to those companies to kind of get in the door and be able to offer them some targeted assistance. So the POTWs reached out ahead of time because they had an existing relationship, and then OTA followed up with those companies to say, hey, we understand your local wastewater treatment facility mentioned to you that we were going to be getting in touch. Here's what we can do for you to try to help you identify where there might be PFAS in your operations. Next slide, please. And a little more of what we're offering them, you know, the first step is, you know, figuring out if they're using PFAS at all. So I talked a minute ago about the supplier notification template. We also started developing these assessment tools, basically industry-specific surveys, to see if there were any red flags for specific applications where we might expect to see PFAS. We borrowed some content from some work that had been done in some other states about identifying potential and probable PFAS sources. Heather has talked through a lot of examples of you know, places where we tend to see that. So that was all incredibly helpful in starting to narrow down content for these questionnaires. So OTA identified 4 industries where we felt like we had enough information to do that work. We've already drafted surveys for the paper and metal finishing industries, and we're preparing to start conducting those soon, probably in the new year. And looking ahead, we're also planning to develop them for manufacturers of coatings and textiles, but that's still a little bit early. So when we administer these surveys, an OTA technical staff member will walk the company through each question. We're hoping to also develop a self-serve tool, but we're not quite there yet. And we're asking participating companies, if they do have a list of CAS numbers, to share that with us so that we can cross-reference it with existing lists. Heather mentioned earlier that list of PFAS currently in commerce that's going to be kind of tagged to, is this, you know, covered under TURA, is this not? So we can do a little legwork, and our colleagues at TURA can assist to see if a company is using an PFAS and has that CAS number already, or if they're using a product that we believe contains PFAS. We're also going to encourage companies to allow us to add the names of any PFAS containing products they're using to an informational list that we're developing. Next slide, please. And the hope is that once we develop a list of products that are known to contain PFAS, we can make that publicly available and offer it up to companies so that they can make some informed purchasing decisions. And this might also highlight some places where safer alternatives are available and where they may still need to be identified. We're also hoping to identify, you know, non-PFAS containing products that are in use that we might be able to offer up as alternatives that meet some of those same needs. And as you know, Heather alluded to, there's TURA is doing some work on a database of PFAS that'll be included in the NOL listing. And that's something that OTA will also be able to consult to help your company or a company you're supporting figure out if something they're using is on that list. So I'll hand it back over to Heather here, and she'll finish us out.
Thanks, Carolyn.
And Heather, before you jump into this next part, which is so important, Beth asked a question, which I think is a good one. If something is proprietary on a safety data sheet and a supplier isn't forthcoming with information, would we need to do anything beyond documenting the attempts to obtain information?
Yeah, and that is a great question.
I think that's kind of what we were getting at. I think we kind of addressed that when Liz and I were responding to, you know, first of all, that's a good starting place. Secondly, you know, loop in OTA, loop in other TURA bodies so that they can do a little bit of that outreach as well.
And we could talk about that further if that's still a question. Maybe at the questions at the end. Bill, did you have a question?
Yes, I just, you know, dealing with chemical companies since the mid 80s and actually working for one once and, you know, for a couple of years. The whole idea of proprietary chemical, when they're talking about 40, 50, 60% of some of these materials, I don't know how they're going to get away with it. I think if you request it, I think they'd have to give it to you. I know they'll all fight me on that, but when you're down around 1 or 1.5% of something, that's a whole different ball game than 50 or 60%. I think EPA will become extreme, or the regulators, whoever that group of people is going to be collectively, is going to get aggravated with that whole thing and not put up with it. So with the ones on the EPA list, I know they're already feeling that way. Some discussions I've had, and I would think that Mass DEP would also be that way if it's proprietary. But you know, it's 50 or more percent. More than likely, if a company uses very much of that material, they're going to trip using it. So there's a legal issue, I think, that's going to be hanging with that type of situation. And I just think it's important that we keep that in mind going forward. That's all.
Thank you, Bill.
Yeah, that's a great point. Tiffany also, Tiffany Skogstrom, our OTA director, also points out that it's a good idea to maintain any communications that you have with your chemical suppliers when you reach out to them. So if you're, you know, if you're talking to a vendor or talking to the manufacturer of a product, please retain those communications, and you can always use them to point to them later and say, hey, look, I tried. And you know, that information, if anything they do provide that is helpful, we also would really love to hear about it. If you do learn about PFAS contained in products, the TURA program would certainly find it very valuable to know about it. And I'm sure, you know, we would really like to be able to make that information available to companies overall so that they can minimize their use of these substances.
Carolyn, if I could say just one more thing.
Yeah.
most of the chemical manufacturers that I've reached out to, when they say it's proprietary, if you're willing to sign a non-disclosure agreement, and especially with this category, because you don't really have to know what that material is. I mean, you do as an end user, but in terms of what's reported, you don't have to say what's in that category.
Yeah,
can
you don't have to know which one.
Exactly, right. So that's all I wanted to say. Thanks.
Yeah, that's a great point.
Yeah, so that is one of the benefits of a category is we don't need specific information on which one, just whether it meets the definition or not.
So one of the other things I mentioned in the chat is that we see more information on very recent safety data sheets. So if you get one that's 2021, it's much more apt to have more specific information. And that's because, you know, companies are seeing the writing on the wall here too. Maybe at the end, we want to talk a little bit about the EPA's PFAS strategic roadmap. They can see that this is coming, and so they're starting to be more transparent about these substances.
Yeah, so that's great to hear that the more current SDSs are more descriptive. Okay, I think we have about 10 slides left, and then we can talk a little bit further about questions and such. So this last section is some example PFAS, and we'll talk about why they don't meet the definition. So I know it's too early in the morning for chemistry, but whatever. Here we go. So over on the left here we have description of carbons having 4 bonding sites taken up by hydrogen here. And at the top, we have a simple hydrocarbon alkyl chain. And over to the side, we have a branched example. And then at the bottom, we have a perfluorinated alkyl chain where all the hydrogens have been substituted with fluorine. So this is a typical looking PFAS. And then I added another slide with that proposed definition repeated from earlier in the presentation. So, the PFAS NOL category would contain PFAS that have a perfluoroalkyl moiety with 3 or more carbons, or a perfluoroalkyl ether moiety with 2 or more carbons that aren't otherwise listed. So I just wanted to repeat that here. So here's a couple examples of PFAS that are included in the definition. Up on the left, we have CAS number 336083. Some of us do best with CAS numbers. Some of us do best with structures. So I didn't write down the name of the substance, but I've got its CAS number, which is always so handy. And we can see that we've got 4 perfluorinated moieties in a row here. So we got 1, 2, 3, 4. So we got more than 3, and that would be included in the category. At the bottom,
Heather?
Yep.
Maybe you just want to back up to the previous basic slide and just say why those chemicals are, that one, are perfluorinated.
Go ahead, Liz.
So if you look at that carbon having 4 bonding sites on the left there, that is critical to understanding when something is perfluorinated or polyfluorinated. So when it's perfluorinated, that means all those hydrogens have been replaced with some other substituent. So whether it's another carbon or a fluorine or whatever. And so when we're looking at these carbon chains and these other molecules, then you just want to check to make sure that there aren't any hydrogens left. And if that's the case, then it's a perfluorinated carbon. So step back.
Thank you, Liz. So, so on the right here, we have HFE 7100, I think. Anybody want to take a guess or explain why this is included in the definition?
Be brave.
I'll try.
Thank you.
I think it has at least 3 of those FF branches.
Yep.
Okay.
And here's another chance to note that the one on the end on the left actually has to have 3 fluorines because it's got 3 bonding sites that aren't its adjacent carbon. When that F3C is connected to another carbon, in case you don't remember your structures, that next little bend in the chain is a carbon with the 2 fluorines on it. So the 2 fluorines account for a perfluorinated carbon there, and the end one has to have those 3 fluorines. You're absolutely correct. And this one has actually 4 perfluorinated carbons, so that's more than 3. It also, Heather, just a step back, it also happens to be an ether. So is it, does it qualify under our definition of a perfluoroalkyl ether? That means there's an oxygen within the carbon chain, the ether.
Yes, because
I
there's
guess that's
more than
yes.
2.
Go ahead, Lucy.
Yes, because there's more than 2. Is that what the ether definition?
That's correct.
Is
About
more
the
than-
ether definition is more than 2.
Right.
Right, but is the carbon on the right side of the that ether linkage, is that fluorinated, perfluorinated?
No.
Right. So we're trying to take the strictest reading of what the SAB had for language. So we would say that this is not a perfluoroalkyl ether moiety because all of the perfluorinated carbons are on one side of the ether linkage.
Oh, geez. What's the difference again between perfluoro and poly? You were trying to explain that?
So if the one of these carbons in the chain in this HFE chemical only had 1 fluorine on it, then the other bonding site would probably be a hydrogen.
Mm-hmm.
So if this diagram just had 1 of those Fs on one of the carbons instead of 2 Fs, then that would likely be a polyfluorinated carbon.
Okay.
So
And the carbon on the right is not fluorinated at all.
So the upshot is this is included, not as an ether, but it meets the category for the perfluoroalkyl, more than 3 perfluoroalkyl moieties, right?
Right.
So, and this is a great example of the sorts of things that we've been struggling with as we look at each substance and see whether it meets the definition. It is incredibly tricky.
OTA will be there to help you.
We have a question here. Jane asks, would 1 hydrogen anywhere make it not perfluorinated, or would it still be included because some of the carbons are completely fluorinated?
So that would depend, it's a great question. And that would depend on where that hydrogen was in the carbon chain. So again, we're trying to take the strictest reading from what the Science Advisory Board had for language, which says that 3 perfluorinated carbons have to be contiguous to one another in a chain. So if that hydrogen were in the far right carbon that has 2 Fs now, if there were only 1 F there, or in the far left, then it would still qualify. But if it were one of the ones in the middle, then that would mean you'd only have 2 contiguous perfluorinated carbons. Does that make sense? Maybe if we go back to the reasoning for this, it would help. It's not just an arbitrary designation. As Heather explained, the Science Advisory Board looked at the ultimate degradation products for these chemicals, which went down as short as PFBA, which has 3 contiguous perfluorinated carbons. And so that is an ultimate degradation product of some of the other chemicals, like the one you see on the left. And so if it couldn't break down into that chemical, then if it would only break down into an ultra short, meaning only 2 carbons that were perfluorinated in a row, then they didn't look at the ultra short carbons, at the ultra short PFAS. Therefore, we're trying to say all the precursors need to be able to break down into one of those chemicals that they did study. Does that make sense?
It's all very challenging.
Yeah. Can I just ask, and I know, so TRI put out the 172 bigger chain
Longer
chemicals,
chain, yep.
right? Longer chain chemicals. And the reason, just kind of taking 10 steps back, the reason why this all was a concern to SAB is because they feel as though the listings from TRI don't go far enough in the degradation process. Like they don't account for the things that ultimately degrade or.
Right. It won't prevent use of the things that degrade into those end degradation products in the environment.
I think also part of your question is about why isn't the TRI listing enough? And that you have to go back to Heather's timeline and when the SAB was studying this and when the National Defense Authorization Act added those chemicals. Right, Heather?
Yeah. I mean, I don't have a ton more to say about that, but.
Yeah.
Yeah. But so there's definitely a lot of shorter chain chemicals that the SAB thought were, or, had evidence for that they were hazardous and of a concern. And it's just that TRI listing is still only for chemicals that EPA has a significant new use rule for and are expected to be in commerce. And so the only ones they've ever done SNRs for are the longer chain chemicals. I just want to reiterate that OTA and TURA are here to help you. And we know that this is complicated and either agency is very happy to help with whatever questions you have.
Yeah, and we're really attempting every time somebody has a question to document it and the answer so that we can provide, those materials to people. Yeah, so the more questions you ask us, the better it is. We'll keep track of them and document them and either put them in guidance or supplemental documents to help people out. Daryl?
I was just going to say one of the things I think for the difference between this and EPA and TRI is that EPA on its own website, epa.gov/PFAS, which I don't think I've seen in the past, them dedicate something that high up in the address directory for a set of chemicals, is that they feel that they are way behind, but their processes, I think, are very long to be able to list something. So they've expanded it by 1 in the last year. So I appreciate this effort.
Thanks, Daryl. Okay, we'll move on to a couple more examples, and then I do want to at least leave myself some time to talk about resources available to filers. So here we've got Nafion. We've got at least 3, more than 3 perfluoroalkyl moieties. And we've got a benzene ring on the end, but that is okay.
So actually Nafion's the next one.
What?
We got them on the same slide before. We tricked each other. We moved them on.
Okay, sorry. All right, everything else is true about this one except for it's not Nafion, sorry. Okay, this guy, yeah, is too much. Clearly it's too much. Liz?
Yeah, so there are a couple of things, if you're not used to reading chemical structures, that you'd see here. One is the brackets. And what that means is that it's a repeating moiety. So if you look up in the upper left where it has CF2 in between 2 parentheses, that means that that's going to repeat X number of times. So that tells you right away that if it repeats more than once, then you already have the full chain. You can definitely see more than 2 perfluorinated carbons in a row there. And then Nafion also has side chain polymers there. So you can see, again, more chains off to the side that qualify under a number of situations, both as an ether, as a perfluoroalkyl ether moiety. You can see the oxygen with perfluorinated carbons on either side, and also just for the number of fluorinated carbons.
And I'll just say, you know, some of us are CAS number people and some of us are chemical structure people. And you can tell that I completely check out once I see the chemical structure. I just want a list of CAS. Just somebody give me a list of CAS numbers. But, you know, clearly the chemical structures are, you know, going to be important to figure some of this out. But if you're someone who that's too much for, which I am, there are people in the program at OTA and TURA that will help you with that. So, so we know that there's going to be a lot of assistance needed with that. So I think this is the last one that is included, the last example that's included in the definition, and it's Gen X. And I know it's Gen X because the chemical name is part of the image. So no mistakes I can make there. So here's Gen X. So this is an example of a PFAS, a perfluoroalkyl ether that would be included in the definition, except for it's also one of the TRI substances. So, so would defer to reporting there. Couple examples of PFAS that are not included in the definition. Liz, you want to take these?
Sure. So when we were trying to explain before about how the perfluorinated carbons had to be contiguous to one another, if you look in the upper left, then you'll see that every other carbon is not fluorinated at all. It has 2 hydrogens and the other 2 bonding sites are to carbon. And so it goes perfluorinated, not fluorinated at all, perfluorinated, not fluorinated at all. And that is the structure of PVDF, which is a common resin. And so that would not fall under the definition. And the same with the one in the lower right. So that also is a polymer. That N and the brackets tell you that structure repeats. But assuming that it is perfectly made and it's always, they'd say, you know, head to tail, meaning the next one goes with the hydrogens on the left and the fluorines on the right, then you would not end up with 3 contiguous perfluorinated carbons.
So that partially gets to one of the questions we were just asked. Right. So I'm going to move on from that because I do want to make sure that we just have a little more time on the resources. So we do have one example here for as Teflon. And this was a question I was asked about at a recent presentation that I stumbled right through. Here's some clarification after, you know, talking through the whole thing. So PTFE, for example, Teflon is included in the proposed PFAS NOL category. If you've got PTFE pellets that are being processed, such as an extrusion process, or PTFE that would go into a coating emulsion, those would be reportable. Teflon articles, such as Teflon tape or spacers, would likely meet the article exemption. And then the monomer, TFE, used in the manufacture of PTFE is not included. It doesn't meet the proposed PFAS NOL category, but it is actually individually previously listed under TURA. So, you know, as we just saw with these last 10 slides or so, it is pretty complex, and we know that. You know, there's going to be a steep learning curve here for everyone, but you know, the program is definitely dedicated resources to make sure that we're answering these questions and trying to work through it as easily as possible. So here are the things that we're planning on providing, both the definition and like some further explanation about the definition, the list of TRI chemicals, and we actually have a database that we can put all these lists into. the list of chemicals, the list of PFAS that are known in commerce from TSCA. That's great. And that narrows things down from like 5,000 to about 600. The only problem there is CBI, unfortunately. So we're pretty interested to know whether that longer list of PFAS from OECD is helpful for people or not. That's about 5,000 PFAS. And then, you know, whether example structures or otherwise are helpful. And again, as we mentioned, we're trying to keep track of all the questions that people are asking so we can provide answers to that in an easy place for people as they're figuring out their reporting. So is there input on what would be helpful for people to see?
Heather, I think I must have missed something there. You said that the 5,000 would be reduced to 600.
So the
go ahead.
Sure. Yep. So the 600 are the ones that are on TSCA that we know are in commerce. So the 5,000 is kind of theoretical. So I don't want to say that it's reduced, but I'm saying that it's easier to focus on the 600 we know are in commerce in terms of like providing lists. Again, it's the CBI is problematic there. So I guess part of the question is, in the guidance, if we provide the list of TRI chemicals, because those, like you defer to, if it's on that TRI list, you have the 100-pound reporting threshold, and you individually report that PFAS. We did something similar for C1 to C4, where we provided the halogenated compounds that we knew people, knew were in commerce. So we thought it would be helpful to provide the list of the ones that we know are in commerce for people. And we felt like the 5,000, theoretical substances might be like a lot. But that's something I'm asking you, what's helpful for guidance?
Definitely the CAS numbers. There's a lot to look at.
Yeah.
And, I don't have an army of chemists that can figure it all out.
Right.
Yes,
Right.
I would say if we could get that list of 600, like in Excel, that we could import into, we have a dashboard for our clients and we have automatic lookups. That could be very helpful. We've already put the 172 TRI in there and other stuff, but having it in that format so it could be, imported would be great.
Okay. Bill?
Yeah, I agree. We also have a global operation, and they provide a tool for all of our sites. If we had those CAS numbers in that tool, it would be so much easier to do the hazard evaluation of chemicals that we already have. And then those that we get requests to bring in, whether it's for R&D or other needs.
Go ahead, Bill.
The OECD database is searchable, and there's a lot of material there that does not have CAS numbers, but at least you can search on chemical formulas. So I'm hoping that'll be helpful to people. I know the list of 600 is EPAs, but these lists, if they're in one Excel file, not necessarily combined into one sheet, but in one workbook, those would be 3 lists that you could really search. And just for clarification here, we're not talking about the NOL category taking in precursors, right? It's only those that are PFAS. Is that correct?
So it includes precursor chemicals. That just means chemicals, PFAS chemicals that break down into the end degradation products. So PFAS includes precursors.
Okay, I just read the definition. It wasn't clear to me for some reason.
Yep,
Sorry,
that was
Liz.
a great question, Bill. And yes, it includes the precursors. And interestingly enough, that TRI listing also includes precursor chemicals that they have significant new use rules for. One other place that you can look is on EPA's CompTox database, and they have about 9,000, as Heather says, more theoretical chemicals that they're aware of listed there that are PFAS. And that is like the entire set of PFAS, not just what the TURA program has defined from the SAB's work as our certain subcategory of PFAS.
Can you post a link to that?
Yep. Actually, what we'll do is make sure it's in the presentation that gets posted. How's that? Because I know Heather's probably trying to move
Thank
along.
you.
I think the presentation's already posted, Liz. If you want to put it in the
Okay.
chat, go ahead.
We'll do that.
Okay, so yeah, I'm going to try to end on time, but we'll stay on for any additional questions. Daryl, I know Daryl's got her hand up, so go ahead, Daryl.
When you talk about doing testing, if you can't find satisfactory information on SDSs, testing is complicated for PFAS.
It
There
is,
aren't,
yeah.
there aren't procedures yet for everything. One could
Yeah.
do maybe the total organic fluorine test.
Yep.
But then what do you do after that? I'm just wondering how far one can even practically try to go down that path when it's an
Yeah.
unknown that you're testing for.
Yeah, you're completely right about that. Testing, as with anything with PFAS, is complicated. So yeah, and you don't have to, you definitely don't have to go down that path at all. It's just, I just wanted to mention it as an option to, you know, to do some double checks. You know, if you do a total organic fluorine and something turns up, then maybe, you know, you're realizing that one of your suppliers hasn't given you accurate information and you need to work harder. And that's more really like, you know, to protect your company's liability rather than, you know, figuring out your TURA reporting or reporting for anything else. So it's just another tool.
So it
But
could be
I
like a
agree.
screening.
I agree. It's completely complicated. It's definitely complicated. So I'm gonna skip my next slide, but it's there. It's there on the website. So just, you know, back to why we want to bring a preventative approach to this. This is the Massachusetts map. The green are water supplies and public water supplies in Massachusetts that are above the Mass DP MCL standards that recently came out. And, you know, it really makes sense to look past the substances that we know the most about and the ones that are, you know, that we have test standards for and such, and think about the substance, you know, the PFAS that were used to, you know, that ended up in this in this contamination. So we're trying to take a preventative approach here to add to a lot of the other great work going on from Mass DP and Mass DPH, and you know, increase knowledge at facilities about using PFAS, increase knowledge, you know, at a minimum of using them as safely as possible, and you know, eventually move towards alternatives and such. But it is a really deep learning curve for all of us. I mean, it's still going to be a deep learning curve for the program in terms of who's using, and certainly as we saw here with the companies about determining whether they need to report or not. And we've definitely, you know, planned program resources to help people along through this kind of complicated effort. So I'll end with that, but we'll definitely hang out to answer more questions.
Can I ask a quick question?
Yeah, hang on one second, Bill. I just wanted to mention to everyone that it's worth looking at the PFAS strategic roadmap that EPA has put out, because it lists a lot of things that they intend to do around PFAS, and it may largely involve the longer chain substances. Nevertheless, there's a lot of work that they have planned. So it's worth taking a look at that. Go ahead, Bill.
I just wanted to say that recently there was the EPA NERPCA 23rd Annual Conference. Tiffany gave a good presentation there in terms of where the Massachusetts regulations and partnerships are. I think it might be helpful to people if they understand, have a little bit better understanding where this whole thing is going and how we're going to get there, such as going back upstream, or I'm sorry, end of pipe completely to the POTWs they test. They're trying to go back upstream. Who's putting these materials in the water and what it's going to mean for them going forward. So there was a lot of good information there. I don't know how much could be posted to all of the people today who are listening in and looking in, but I think it's important that people really understand that it's just the beginning. And although the analytical testing, the EPA standard methods, there's not a whole lot of them there for other than drinking water, that I'd say it looks like within 3 to 5 years, companies are really going to have to start knowing what they're putting in the water and what quantities. Do you agree with that?
Yeah, I mean, I agree. And, preferably even before 3 or 5 years, to avoid any kind of liability situation, but, using something that degrades into one of those degradation products that stays in the environment.
So I don't know if her presentation is one that could be posted, and Jay Pampar also gave a good presentation of where things are. There was tons of good presentations during that conference, but there are probably a couple there that would really help if we can get permission to add those to this list of things for people.
Thanks so much, Bill. I really appreciate your kind words. And